Nice to meet you all. My name is Jon Zeolla. I'm going to be talking a little bit today about infrastructure as code security at scale. So just a quick introduction about me. So I am the CTO and co-founder at a security consulting company called CISO that I started about 5-6 years ago. And I do a lot of DevSecOps, cloud security, zero trust work there. I'm also an associate instructor for SANS Sec 540. So that's the cloud security and DevSecOps automation class. I'm based out of Pittsburgh, Pennsylvania, and I like to run a lot of different events. So I run the local B-Sides Pittsburgh chapter, a group called Steel City InfoSec. I also made a group called PitSec, which is kind of an amalgamation of all the other groups in the area. I just love kind of community building and learning from and teaching other people and figuring out how all this stuff really works. And what we're going to talk about today is the scaling issue. But before we talk about the scaling issue, we have to talk about how most companies get started in infrastructure as code. And specifically, I'm going to be talking about Terraform today, although this solution applies to lots of different infrastructure as code. Just to simplify the conversation, we're going to talk about Terraform. So when a company is first developing Terraform, typically it'll look a little bit something like this, where you've got all of your Terraform, maybe in one file, almost definitely in one folder of files. And you've got your numerous different resources, in this case, an AWS Lightsail instance for my server. And you've got some basic user data, whenever the server is provisioned, run a couple commands, and this is your first infrastructure as code. As you mature, you'll likely find yourself dividing these Terraform files up into modules. So on the left, we've got a main.tf, which is just leveraging a Terraform module. On the right, which is this module called AWS-network. Now, in this example, both components are in one Git repository. So we've got version control and all of the basics that you would expect from that. And you are simply referencing this separate directory to split things up a little bit. As you continue to mature, you probably want to break these modules up into separate Git repositories. And so that's what we have on this page. So you can see on the left, we've got this source example_live repository, then maybe a particular environment, in this case, just called environment, and then you have a main.tf. And that points to a module which is remote. So that module, you need Git to be able to retrieve. It retrieves it over SSH. And you can see on the right side, you've got the separate Git repository of module-AWS-network, and it has all of the things that you would expect. What's interesting about this approach is now you've been able to decouple, whereas previously on this last slide, this is all in one repository. So when you make changes to the module, you're implicitly making changes to the live on the left as well, because you're pointing directly to the latest version of that directory. Whereas here, you're actually able to specify revision tags. And those tags are just Git tags that are in that module AWS network module or any other Git repo that you're using as a Terraform module. And so now you have some decoupling, right? So this is the basic progression that a lot of companies go over as they're beginning to do infrastructure as code. I work with a lot of companies that got to this point many years ago, right? And so we've started to identify that we've got modules, and maybe we've even got submodules, modules that are made up of other modules, and that we have these abstractions now and reusable bits of code that comply with that company's standards. So you develop these modules, you develop lives that point to those modules, you can make updates to both of them separately, and you want to generally maintain newer versions of the modules being referenced by your lives. Sometimes that doesn't always happen, and that's something we'll talk about a little bit later. But that's what starts to happen. You start to build more and more and more Terraform, and you're breaking out into multiple repositories. Soon you'll have 10 repositories, then 20, 50, 100, and likely hundreds of Terraform repositories. So once you have all of those repositories and you've really made the investment as a company to build everything as infrastructure as code, you might be wondering what you're going to do about security. And in this case, security is a bit of a distributed problem, right? You've got all of these modules in different repos, maybe composed of submodules. You've got your lives. and they're everywhere. They might not even be in one version control system. You might be using GitLab for some things, you might be using GitHub for others, or Bitbucket, or you might run something on-prem, and you need to have uniform security across all of those. So how do we do that? So let's talk about when you would first start to do this. What would that look like? So when you first think about implementing security scanning, you probably go out, do a little bit of Googling, find a security tool, an infrastructure as code scanning tool. In this example, that green KICS scan is a great tool made by Checkmarx that's open source and does security scanning. So what this would look like in reality is you probably clone that repository. In this example, the example_live is the name of the repository, and there's a couple folders in there, environment 1, 2, 3. Now, once you clone that repository, you need to change into the right directory. You need to run your Terraform init. That'll pull down all of your modules, your providers, etc. And then you want to run the scan. So the scan is a kind of long, but not too long command, and you'll get some output, which I just truncated to ... Great. So now we've done a security scan of one environment in one live in one repo. Okay. Now we got to do that again. So we need to CD over to environment 2 in that same repo. We got to run Terraform init again because things may be different. And we got to run that same scan again. Okay, we're getting kind of tired of this. I don't like typing all of these commands over and over, or even if I'm hitting up and then enter, it's still a little monotonous. So let's speed it up a little bit. Great. So now we're going to CD into environment 3, and we're going to use this &&. So if the CD exits with a 0, then it'll do the Terraform init. And if that succeeds, it'll run the KICS scan. Great. And that's still not entirely what I was looking for, though. I want to be able to do a whole repository at once. And this is kind of the progression that I did working with a few of my company customers. So now we made it so that you can go into an example live top level directory, and let's do automatic discovery. So for environment in a find command, we're just grabbing all of the directories. We're jumping into those using push D, running that Terraform init in the KICS scan, and then we're popping back out of that directory, and then you go through and you do the next one. So now we have a single command that runs KICS in each one of these directories, and for at least this one repo, it works pretty well. Until you run into some sorts of interesting issues. One of those issues that I ran into just a couple of days ago is when you run that Terraform init in an environment, it might be written with a minimum Terraform version of 1.0, and you might be running version 1.1. So what do? Well, probably what you do is fail. The Terraform init will probably fail, especially if that stuff is required in there as a min required, and then you need to change your Terraform environment. That can be a little bit monotonous. We'll talk a little bit later about how I stayed up late last night and solved that problem. But so let's go back to the bottom command here. We've went to an example live. We ran a for loop through all these different environments. We ran this KICS scan, and we have some results. Great. So let's look at what those results look like. Okay. So if you're anything like me, you probably took a look a little bit like that. 12,000 findings, 2,500 highs, 3,500 mediums, et cetera, et cetera. So in all of the free time that you have, you now need to go triage all of these and identify which ones are real findings, which ones are false positives, how do you tune your roles, and what do you do from here? But this information that you have is really only focused on one environment, right? One Git repository. And again, we're talking about scale here. We're talking about dozens or hundreds of environments, all of which might have findings like this. And here's a interesting note. That's actually a real result summary from a repository that I ran some scans on. And so this sort of thing does happen. So, all right, there's a lot of findings. We get it. Okay. But let's keep digging in. Let's start to triage these findings, get a ballpark. All right, of these 2,500, let's take a 1% sample, right? Just a 1% sample. Let's do 25, 30 of them. And let's see, what do we have? So you start to look into these findings, even though there's a lot of them, begin to triage them, and you say, things look a little bit weird here. I'm not sure that this is actually an issue. And then you start to look upstream, look at the project that you chose, and maybe you'll find something like this. So this is a known gap in the Checkmarx KICS open source project, which says KICS does not support unofficial or custom modules. So that means that if you followed the book Terraform Up and Running, which is a great book, highly recommend it for operational Terraform, and I heard that they're coming out with a third version soon. So you ran that, you split everything into lives and modules, and you picked a tool, you put all this effort into that tool, and you find buried in some documentation somewhere that it doesn't support that design at all. So this is the moment that you realize you've made a mistake. So we've invested all of this time. I got a large number of findings. I can't even reasonably triage them all. They're all stuck on my computer. They required manual effort, and they didn't even support the design that my company chose. Very common scenario. So now what? So the good thing is that you have options. There are multiple different infrastructure as code scanning tools. And in fact, there are actually many more than this, but this is a screenshot from the repo tool compare, which is one of my favorites. It's a quite lengthy comparison of these different infrastructure as code scanning tools to identify whether they hit or miss on different types of vulnerabilities. And this is their summary table, which is towards the top, and just talks about what the license is, who's the vendor that's backing it, and various other things. So one thing that's notable from this is that not all of these are open source, right? The Sneak and the CloudRail projects are freemium, and the other ones are actually open source. But as you can see in the bottom, not all of the open source projects have all the features. You know, for Checkov and for Terrascan, you have to pay for these live environment scans and potentially other features like embedding it into your IDE so that whenever you're writing something, you can know if it's secure, or your dev teams can. It's also very important if you look at the third content row, the custom role support here, that a lot of these do support custom roles, and they're written in different languages right here above there. So if you prefer Python, you might want to lean a little bit more towards Checkov. If you prefer Rego, KICS or Terrascan are good options. And if you are if you're a team that's really good at Go, you might want to do TFSec. So there's lots of different options. If you care about those custom roles, you might care about those languages. If you're just looking to use out-of-the-box roles, it might be a little bit less important to you. But you want to take these, you want to be able to run these different tools, get the output, and then leverage them somehow, right? Like, we're about results. What our goals are here is running security tools to gather information, identify real risks, real scenarios that could cause your company to be breached because of how the infrastructure as code is designed, and either prevent those from happening or detect that they exist and put plans in place to fix them. So we've got all of these options, different decisions that you can make, and then each one comes with its own set of nuances, and then you need this whole thing to scale. So what do? Well, what I did about 2 years ago is I wrote a tool. And as I started talking more about this tool, I decided to get a logo for it. But so the tool is called Easy Infra, or short for Easy Infrastructure as Code. And this is not just a security tool, but this is really an infrastructure as code tool. So it's meant to be generic. It's meant to provide features that I didn't see in other pipelines, simply for just deploying infrastructure as code in these sorts of designs, high scale infrastructure as code environments. And the part that brings us here at the talking about security is that all of the security mechanisms are added transparently into those workflows. So this is really a tool that supports typical infrastructure code deployment pipelines and workflows that has transparent security added into it. So how would we get started with a tool like this? So we'll go through a quick 3-phase progression where you will start with just using this bare bones and then progressing until you're actually stopping developers from writing insecure code and deploying it into your environment. But what you don't want to do is be somebody who jumps in and starts with that last stage first, where you're blocking developers from getting their work done because vulnerabilities are identified, because for all we know, this is one of those 12,000 false positives. So phase one, we're going to use a very simple example. We're going to have a repository called example live, and it is designed like this. It has an environment 1 and an environment 2, and each one has 2 different types of Terraform files. One is insecure, it has some sort of security vulnerability, and the other one is secure. And we're also assuming right now that all of these are valid Terraform. If it's invalid Terraform, we have ways to handle that too, but it's a little bit separate from this conversation. So we have this repository local on our system. Again, we'll talk about scaling this up, but how do we make this local process easier for us? So we make a Docker image. So Easy Infra is a series of different Docker images that exist on Docker Hub. And so you can run a Docker run CISO Easy Infra and pass it a command like Terraform validate. Terraform validate is a very common command for validating that these things are valid. And it's used in a lot of linting. And so it's very common. And I use that in a lot of my examples. We also are going to do this TAC-V, which is a volume mount. So what we're going to do is take the current directory, this source example live, and we're going to put it into this /IaC directory, just some arbitrary directory inside of Easy Infra, which is going to be the working directory of this Docker image. And we're going to pass two key environment variables. And this is highly recommended if you're going to start using Easy Infra, how you begin to do that. Set these two non-default variables. First, disable security equals true. I tried to make this as explicit as possible. We are literally disabling all of the security features of Easy Infra right off the bat. And then we'll also want to turn auto detect to true. So if you recall a few slides back, when we had an environment like this, we had to find each folder, each directory, move into those directories, run a command, pop back off, and go through a loop. Auto detect does that for you under the covers, and does some other pretty cool stuff too, which we'll show you hopefully at the end if we have some time. But we are disabling security. The goal of this step is really just to start using Easy Infra in your pipelines and to see if all of the baseline functionality, the non-security functionality, even works for you, right? So taking it slow and very cautious, you don't want to be failing builds and causing issues. So when you run this command, you're going to get some output. So that output is typically going to be, if the Terraform is valid, success, the configuration is valid. So this output is actually from Terraform itself, the Terraform binary. It provides an output when you run it on each of the directories that you ran it on. So technically this would happen twice because auto detect is on. And so it would run it in here and it would run it in here. The other thing that's important here are these question marks. So when Easy Infra runs against a repository, it gathers lots of information. That's one of the main use cases of this project, is gathering security intelligence and information about an environment. Now, in this case, because we've set disable security to equal true, it's not even running those tools. So it doesn't know whether these are secure or unsecure. So it's just got these question marks. Those question marks are logs. They are JSON logs that are properly formatted as ECS, and they can be sent to a cloud. In fact, they can be sent to many different clouds and different environments. There's native integrations built into Easy Infra to go right into your Splunk environment, into Elasticsearch, CloudWatch, Azure Log Analytics, Syslog, and a whole bunch of others, somewhere around 35 different integrations we support out of the box. All you have to do is provide credentials, if credentials are required, and a basic configuration on where these endpoints are. So with this first phase, we are running Terraform Validate in repositories, turning all the security tools off, and just gathering some basic information. That gathered information will let you know if the thing is even running, if it's even succeeding. But what's also really interesting is it will tell you explicitly that it ran and disable security was true. So this, if you were in a higher maturity environment, would actually allow you to detect if developers or somebody had decided to turn off security for their pipelines when you were in security enforcement mode, expecting it to block. You would have now centralized logging and information that that thing was happening in one place. And this is irrelevant on which Git host, Git environment you're using. So if you're using GitHub or GitLab or Bitbucket or anything along those lines, it's irrelevant, right? If you are able to run a Docker image and you have network connectivity to your SIM or related log aggregation function, you can get that and gather that information and identify who's running it and who isn't. And sometimes it might be okay that they're turning security off, and sometimes it's not. So after phase one, after we've identified, okay, the bare bones Easy Infra works in this environment, what do we do now? Okay, we're gonna gather some more information. Same environment, same setup here. We're gonna run a slightly different command. So you'll notice that auto detect is still true. Everything else about this command is the same, but we have learning mode equal true, and we're not specifying disable security. So if you don't specify disable security, it is false. We have security by default. But learning mode will run all of the security tools that are in Easy Infra. And if you quickly go back to this slide, 4 of these tools are actually in Easy Infra, and you can choose which of them you use. You can use all of them, you can use 2 of them, and you can specify the combination that you run them in as well. But learning mode means that it's going to attempt to run all of them and gather some information. So what happens in that case, remember, we have 2 environments, each with 1 secure and 1 insecure Terraform file in them. We're going to get some feedback. So this passed checks, we're going to show 3, failed checks 4, and skipped 0. So this is just the example environment I made on my local computer for these slides. It only had 7 relevant checks. And the insecure ones obviously failed. So we can see here an exclamation mark. There's something interesting about them. The checks did actually fail, but the success, the configuration is valid. Okay, so with that, again, this is Terraform saying that it's valid, and that is also showing that this command would succeed. So even though we have these insecure Terraform files in our repositories, at least according to these 4 failed checks, we're going to let the build continue to succeed and maybe even deploy into production, right? Our goal is not to prevent everything and have perfect security. We're trying to reduce the amount of time that we have vulnerabilities deployed into our environment. So we want to identify them quickly and fix them. And if we can, prevent them too. So this, in this environment, these 2 insecure findings, as well as the secure findings, would be aggregated and pushed to your Splunk environment or wherever you host that. And you could have a dashboard saying, okay, now that we're on phase 2, we're using learning mode equals true, disable security false. I know where our problems are. And this is the stage where you usually take a step back and you say, okay, let's take a look at what this looks like. What are the actual findings? Who can I talk with? Who can I work with? Let's find our hotspots. What have the most vulnerabilities? What have the most true positive findings that are our biggest concern for us? Maybe we just say, we care about unencrypted S3 buckets. Maybe we care about public S3 buckets, unencrypted EBS volumes. Something simple like that is a typical good first step. Let's look for just those roles failing or having issues, and let's go find the repositories that are relevant, and let's work with those teams to fix them. Again, the builds are not failing. We are scheduling time with these developers. We're putting on their backlog. We're asking them to prioritize it, but we're not failing the build. We work with them. We might even contribute as a security team to make these things better, run the scans again, because this would happen every single time that they're running a deploy or a merge or even a pull request or merge request. And we'll see if it succeeds or fails, and eventually hopefully get them to succeed. So we would have all green checks. That indicates that we can likely move to the last phase of maturity for this presentation, which is security enforcement. So same environment, we're going to run a command where we don't specify learning mode or disable security. And in this case, it is actually going to fail when it detects those vulnerabilities. So whichever tool detected those, in this case, Checkov, found vulnerabilities in these 2 insecure Terraform files. It will fail the build, and it will also give you a bunch of details. Those details will both be in your CI/CD pipelines, depending on where you place this, and it also can be aggregated in your log. So it's not one or the other, you get both. Now, up until this point, we've been talking about solving each individual repository, in my opinion, fairly well, but we haven't scaled it out. So now how do we scale all of this out? So I'll give one brief example. It's the most illustrative, but you can map this concept across a lot of different CI/CD pipelines. Let's talk about Jenkins. So if you look on the left, this is a typical pipeline in Jenkins for Terraform. You've got a test and a deploy. You run a basic, a init, and a validate in one stage, and then you're running a Terraform apply in the others. You might want to be a little bit more complicated than this and write a plan out to a file and then apply the plan, etc. That's very typical. I only have limited space on the screen here, so I truncated that down. But at the top, you can see in bold, we have this Docker image running as using as the default agent, which is company Terraform 123. That's probably your company's custom internal Terraform Docker image, or maybe some public one on the internet, not sure. But it's very common to have something that your company uses and prefers, and then align with that. In order to apply the security tools, the centralized aggregation, and a bunch of features we're going to talk about next, all you have to do is change the agent to use Easy Infra. Because it's transparent, there is nothing else that you need to do. You may want to configure different options. You may want to have your own internal fork of Easy Infra, but you do not need to do that. It's as simple as running it in a different container, the exact same commands. And I think that's extremely powerful because almost next to nothing changes with the developer's workflow, right? The developers don't have to think, oh, I have to remember to put that step in my CI or do anything along those lines. They just run Terraform commands. And this is the same, like I said previously, for other tools, Ansible, the AWS CLI, the Azure CLI, all of these things, that these capabilities are built into Easy Infra, but we're just using Terraform as a case study here. So I'll quickly go through the feature list here. These are other things that Easy Infra can do that we didn't necessarily talk about. So some of these we did talk about. We talked about learning mode and centralized logging. We talked about transparently adding that security scanning. But the way that this project is built is it actually uses code generation the whole way through the stack. And so that's for speed, clarity, and for ease of forking. So if anybody is interested in having an internal version of this project, you can fork it internally, run the code generation yourself, and generate some sort of output that is more focused on your environment and cuts out all of the features that maybe the upstream provides. That's very easy to do, and there's no clutter. And it's got documentation. We have Docker image signing with Cosign, a wonderful project from the SigStore folks over in the OSSF. If you're not familiar with that and you do any work with Docker images, I would highly recommend looking at that. It has software bill of materials for every single commit that goes into main. It has vulnerability scanning for every single commit that goes into main, and all of the evidence is retained publicly. It has automated updates. So all of the components, there's lots of moving parts to this, and maintenance is hard. So I automated it. So every Monday and Thursday, because who would do that on a Friday? I wouldn't do that to myself. So I do automated pull requests Monday and Thursday early mornings. I evaluate them. I run my end-to-end tests. If they pass, I merge it. So this project is constantly being self-maintained, and all I have to do is click accept whenever I feel I should. Like I said, it has end-to-end testing. So all of the features that we were talking about on this screen and previously, every single one of them has a full end-to-end test in the pipeline for this project to ensure that we're not shipping broken builds. You can switch Terraform versions. That's cloud CLIs, custom roles, all kinds of different things. One last thing I'll note is that it has the ability to disable with a scalpel instead of a hammer, right? What we did earlier with disable security, that's the sledgehammer approach. We're just turning everything off. But there are a list of different security tools for Terraform. There's 4 of them, and you can turn them off per command, per environment, per tool. So every matrix of that is supported. So I have a few things that I'd like to talk about for the future of this project, but I also have a demo. I'm going to do an abbreviated version of the demo here for timing. Hopefully that'll leave us a few minutes for questions if there are some. So let's make this a little bit more concrete and cut over to my terminal. So I've built the project here. You can see these are different versions of Easy Infra. We have a minimal image. A lot of CI/CD pipelines don't support caching, so we want to make it as small as possible. We have AWS specific versions and Azure specific versions, and then we've got this latest, which is really just everything in there all at once. So if you wanted to do that first stage, what we called the image cutover, you could run Docker run, again, disable security and auto detect on this version of Easy Infra that I have here. And you want to run some commands. So we're going to run Terraform init and Terraform validate. So this is going to run in this general repository. You'll see lots of different color logs going by, but what it's doing is it's not running any of the security tools. It is running the Terraform init and validate that I provided. And because auto detect is true, it's running that in each one of the directories that I have underneath. So why did this fail? You can see here that we have some missing arguments in this thing called invalid. I wonder what that is. It is an invalid Terraform file. And because we ran Terraform validate did not succeed. So the run did not succeed. This does not mean that there were any security issues identified. This is exactly what a developer would expect. So if you're working on Terraform today and you run Terraform validate, if your Terraform is not valid, you expect it to fail, and it will, even with disabled security. But like we said before, oh yeah, you can see here, this is just an example, purposefully invalid ALB listener. But even with disabled security turned to true, you can see that these logs are being generated, and these are ECS logs. And you can see in here for each directory that you're getting these messages about all of the checks were skipped because of this environment variable, and there's lots of other useful things in here. Now you can parse this with a handy tool like JQ because it's valid JSON, and you can see here what I'm doing is identifying all the directories that were covered. So we have these 4 different directories, had files in them, and they all did something. So that's the basic image cutover, just to give you a little bit more transparency there. If you want to go to the stage 2, information gathering, it would look something like this. Again, very similar. We're going to run a Terraform init with auto detect as true, meaning it's going to run it in those 4 different environments. And since learning mode is set to true, the security scans are going to be run, but the exit codes are suppressed. So you can see here failed KICS directory scan and various other failures, but those are not going to fail. So let's go all the way down to the bottom of this. And at the end, we should see an exit code of 0. There we go. The demo gods are agreeing with me today. So just some other basic pieces of information. So now you can see the logs are much longer, much more verbose, lots more information in there. And you can even run different queries on them. So let's see, what are all the different commands that were run, security commands. So here's a quick list of them. And they all had different outcomes. So some were successful failures and some were unknown. We just didn't know what happened. Those unknowns are likely where it tried to run something like Terrascan, but Terrascan wasn't available in the image. And that's on purpose for the minimal image. And so you can even run a command like this, which gives you a list of all of the folders for this repo that would have failed. And so now you know where to look. You gather all of this information, make some dashboards, and you can start talking to your developers and say, oh, this would have failed. Let's talk about why. And I think I'm going to call it there, assuming we might have a couple of questions.